Okay, hello everybody. Hope you're doing good. Just wanted to come on here for a bit. I was working on something, doing some research on the Sigma Octantis. And so what I did was I used ChatGPT to kind of help me put my ideas together and sort of put it in an easy to understand way. So let me share this with you guys. Okay, here we go. Title: Celestial Asymmetry and the Limits of the Globe Model. Polaris versus Sigma Octantis. Introduction. Ladies and gentlemen, today I wish to address a topic that lies at the intersection of observational astronomy and foundational cosmological models. This is not a matter of speculation nor of theory divorced from experience. Rather, it is a matter of direct, repeatable observation of star motion, fixed reference points, and the behavior of the night sky. Specifically, I want to focus on two celestial reference stars: Polaris, the so-called North Star, and Sigma Octantis, sometimes called the Southern Pole Star. These stars and the contrast in their behavior present a profound challenge to the assumptions underlying the standard heliocentric globe model. Section 1. Polaris, the fixed northern reference point. Polaris has long been recognized as a stable, reliable anchor point in the northern celestial hemisphere. Its apparent immobility in the night sky has guided navigators for centuries. What is striking, however, is just how consistent Polaris remains in its position throughout the night, throughout the seasons, and year after year. Time-lapse photography reveals concentric circular star trails revolving around Polaris. These trails demonstrate a highly organized rotational pattern, with stars moving faster the farther they are from Polaris. This increasing angular speed is not chaotic, but perfectly symmetrical, indicating that the stars themselves rotate as part of a coherent system, centered around a fixed point. Such a pattern is consistent with a stationary Earth beneath a rotating star field, not a spinning observer on a rotating planet. Now, if we accept the heliocentric model, we are told that Earth is spinning on an axis at approximately 1,000 miles per hour at the equator, orbiting the Sun at 66,000 miles per hour, and the solar system itself is moving through the galaxy at hundreds of thousands of miles per hour. Despite all of these compound motions, Polaris remains fixed in the same place in the sky. This raises a critical question. How is it possible for a distant star to remain visually stationary in the sky despite Earth's alleged axial tilt and orbital motion? Section 2. Sigma Octantis and the Southern Celestial Instability. In contrast, we are told that Sigma Octantis serves as the southern hemisphere's equivalent to Polaris. Yet, upon examination, its behavior is markedly different. First, Sigma Octantis is barely visible to the naked eye and difficult to isolate. More importantly, it does not function as a true polar anchor. Observers in the southern hemisphere must adjust their telescopes frequently to keep it centered. It does not offer the same stability that Polaris provides. In time-lapse footage, one finds that the southern stars do not form perfect concentric rotations around Sigma Octantis, as they do around Polaris. In fact, the supposed central rotation point in the south is often not even in the same place, depending on location and season. Furthermore, Sigma Octantis is not even visible year-round. This is not due to Earth's orientation relative to the Sun, but because of the sidereal solar day differential. Each night, the celestial disk appears to fall back by approximately 1 degree. Over the course of a year, this gradual drift results in the stars returning to the same positions in the sky, relative to Earth's fixed position beneath them. During a portion of this annual cycle, Sigma Octantis aligns with the daytime sky, making it impossible to see. Not because it ceases to exist, but simply because it is overwhelmed by sunlight. This seasonal invisibility is a result of celestial mechanics, not axial tilt or orbital revolution. This asymmetry between the north and the south is not a trivial matter. If the Earth were a symmetrical globe tilted on its axis, rotating once per day and orbiting the Sun, we should expect similar stellar behavior at both poles. That is, the southern celestial sphere should mirror the north in form and structure, even if the specific constellations differ. Yet this is not what is observed. Section 3. Kinematic patterns of star trails. Let us return briefly to the motion of stars relative to Polaris. These star trails display increasing angular velocity as one moves farther from the center point. The stars on the outer ring of the northern sky complete their circular paths faster, covering greater angular distances in the same amount of time than those closer to Polaris. This behavior of stars apparently rotating around a central axis at increasing speeds with radial distance is consistent with the appearance of a rotating disk-like pattern in the sky. Crucially, this movement is observable and testable. It is worth noting that these trails can be replicated on the azimuthal equidistant projection, with Polaris at the center. In such a model, the stars rotate above a stationary Earth in circular paths. This framework accounts for the fixed nature of Polaris and the increase in the apparent speed of stars as one moves outward. In contrast, the globe model requires not only that the Earth spins, but that the observer's position on the surface constantly changes orientation relative to the distant stars. One would then expect some detectable drift in Polaris position over the year. And yet this is not observed. The consistency of Polaris challenges the rotational and orbital dynamics attributed to the Earth in the heliocentric system. Section 4. The observational impasse. We are thus left with a fundamental inconsistency. The northern sky provides a singular fixed reference point that defies the predicted effects of Earth's axial precession and orbital revolution. Meanwhile, the southern sky lacks such a stable reference altogether, and even features periods when the so-called southern pole star disappears entirely. Why does the northern sky exhibit order, coherence, and a fixed axis, while the southern sky demonstrates instability and vagueness in its central alignment? This is not merely a minor anomaly. In scientific inquiry, when a model fails to predict observed phenomena, or when it predicts symmetry that does not exist, the model must be reevaluated. Continuing to assume a model that cannot account for foundational observational realities is not science. It is dogma. The notion of a globe Earth spinning and orbiting through space, while elegant in its mathematical abstractions, begins to falter under the weight of empirical scrutiny, especially when considering the divergent behaviors of Polaris and Sigma Octantis. Okay, conclusion. In summary, the fixed nature of Polaris and the erratic seasonally obscured behavior of Sigma Octantis raise substantive empirical challenges to the heliocentric globe paradigm. These are not matters of philosophical speculation, but of precise celestial mechanics. If we are to take observation seriously as a guide to truth, we must be willing to reconsider the models that no longer align with what the sky itself is telling us. Okay, ladies and gentlemen, that's it. I hope I made it clear for you guys about the nature of this Sigma Octantis, that it should be visible. If it is that southern star, it should be visible every night. But it's not in the same spot every night like Polaris. There's a difference between what is the North Star Polaris and what is thought of as the southern star Sigma Octantis. And technically, if the globe model were real, we would see Polaris exhibiting the same behavior as Sigma Octantis. That's how backwards it is. But because the Earth's not a globe, we don't see that behavior. Like in my speech or whatever I just made with Chat GPT, it's like, yeah, if the Earth were a globe, Polaris would be doing the same thing Sigma Octantis is doing, but it's not. There's a difference between the two. And that the fact that Sigma Octantis disappears for portions of the year, that's also proof it's not the pole. So I hope that clears up some stuff for you guys. I mean, if there's any inconsistencies, let me know. But there you go. I just wanted to put that out there. I was working on that earlier. And I don't really want to stay on too long. That's it. All right. Hey, God bless you guys. Thank you very much for watching the video. And I'll see you next time, okay? All right. Bye.